Hi there, here I am one more time after a while since the last time I published something in the blog. Even though I have been busy for the last weeks, I managed to get some time to write this article and to make this video because this is something I've been working on for the last 2-3 weeks. It's something that a lot of customers and prospects have asked in the last months. And so I had the chance to work on this. Even though it's not very difficult, there are some nuances that you need to keep in mind to make it work. So it's all about NetFlow traffic. So this is something new I have learned. And what I'm going to do is to ingest this kind of traffic into Splunk by using Splunk Stream, which is an app. We will see this in a moment. And among the different deployment options, I'm going to use the independent stream forwarder, which is the one that you can use in very limited systems where you need to deploy a very lightweight agent. So this is going to be the whole thing. The article, it's a long one. You will see in a moment. I thought it was going to be shorter, but actually there are a lot of moving parts and this deserves a lot of details to be documented. So here is the point. This is the situation. You're a network guy, you have a lot of network devices, and there is something called NetFlow which helps you to track all the traffic happening in your network. So those devices, those routers, are providing the traffic information through a kind of protocol called NetFlow, which was invented or created by Cisco back in 1996. So this is a Wikipedia link, and if you want to learn some more about this, just feel free to click it and go over the whole contents. So this article is not about NetFlow and so all the details on NetFlow, but it is how to ingest this traffic into Splunk and start doing analytics. So once you have this protocol or this traffic identified and you have some collectors providing this traffic, the next thing is how do you move this into an analytics box and you start getting insights out of all this traffic. And most important thing, how can you do this fast and so you don't get retired while you are trying. So we are going to use Splunk, and as you can see, Splunk can be extended with apps and technical add-ons. In this case, we are going to use Splunk Stream, which is an app and also a technical add-on, and it also ships an independent forwarder that you can install in a machine, and then you can from that point on you can start forwarding this traffic to the Splunk Enterprise instance or Splunk Cloud. In this case, we are going to use Splunk Enterprise. So in this scenario, I'm going to use these 3 components. First of all, I need to have a Splunk Enterprise, which is the place where I'm going to do all the analysis. I'm going to use the dockerized version, and this is something I already did in the past in one of the articles I have in the blog. Then we are going to use a Ubuntu Server VirtualBox, and here's where I'm going to install this independent stream forwarder. This is going to be the agent getting all the NetFlow traffic and forwarding the traffic to the Splunk Enterprise instance. And finally, we need to have a NetFlow traffic generator, and I found this one in the internet. This one designed and developed by Brent Salisbury, and it is so there are many ways of running this traffic generator, but one of the ways you can do so is by using a dockerized version, which is very handy given the scenario I'm trying to build. Okay, so there are many different steps. It is very straightforward, but you need to be very organized if you want to make this work. And so I decided to create, if I don't remember bad, there are 6 steps. We will see them along the way. And the first thing we need to do is just to spin up our Splunk Enterprise instance, which is going to be in a Docker container. And very quickly, I'm going to publish a couple of TCP ports for making this Splunk Enterprise instance accessible from the outside world. And the first port is the 8000, which is the Splunk Web UI, and the second one is the 8080A, which is the HEC endpoint. So the HEC, HTTP event collector, is something I explain here, is what I'm going to use just to ingest the NetFlow traffic sent by the forwarder. This is going to be the host name inside the container. This is something we are not going to use, then the credentials, and that's all. So once this is started, we have a Splunk Enterprise up and running and accessible through this URL. So the first thing we are going to do is to spin up this Splunk Enterprise instance. So let me go to the terminal window, and here I have 3 windows that I'm going to use for spinning up the different things, and so this is going to be handy when I start playing around with the different components in this scenario. So here in this screen I'm going to start the Docker container I showed before. You can see it's exactly the same, so we execute it, and after a while, so let me make it bigger. So you can use docker logs -f Splunk, and you will see the different logs of the building process. This is an Ansible playbook provided by Splunk, and these are all the steps that are taken in order to make this dockerized Splunk version up and running. It takes some minutes depending on how powerful your computer is. It will take longer or shorter. Cool, once you get to this message, that means everything is up and running. So it took 1 minute in this computer. It's not a very powerful one, so you have a brand new computer with SSD disks and all this stuff. Probably in 30 seconds is up and running. Okay, so this is done. We have actually, if you type docker ps, you will see that you have, let's make it bigger. We have the Splunk Enterprise up and running with many different ports, redirected ports, in addition to the one we specified. Let's go back to the browser. If we click this button, you will see that the Splunk Web UI is up and running. So we can access Splunk. We have the latest and greatest version of Splunk, 8.03, and this is a brand new Splunk instance. The next thing we are going to do is to install Splunk Stream. Okay, so we are here. In order to install Splunk Stream or any other app or technical add-on, the only thing we have to do is to click and here in the plus find more apps link or button or section, and you will get to this window here, this screen, where you can start typing the application that you want to install, and you will see it in here. Actually, what this is doing, this is interacting with Splunk Base, which is the Splunk marketplace, and you have plenty of free apps and technical add-ons. So we are going to look for Splunk Stream. We will click install, and this is going to ask for credentials, and those credentials are the Splunk credentials that you will use when you access Splunk Base. This will start the downloading process of the application, and finally it will install it. And so once everything is installed, it will ask for restarting the Splunk Enterprise instance, and then it will take some seconds to have the application available. So let's reproduce the whole thing. Click the find more apps. Let's type Splunk Stream. Here it is. We click install. It is asking for credentials, but these credentials are not the Splunk Enterprise credentials. Those are the credentials for accessing the Splunk Base. And so you need to remember the credentials. Let's see if I provided them properly. Yeah, there we go. So this means Splunk Stream is being downloaded from the Splunk Base, and once the application is completely downloaded, it's going to be installed by the same wizard that we are using here, and it will take some minutes, actually some seconds. It will not take that long. Okay, the application has been finally installed, and so we are asked for restarting the instance. So we hit restart now. It will take some additional seconds, and eventually we will be redirected to the previous screen, and we will be ready to move on. Cool, so restart successful. If we log into Splunk Enterprise one more time, we are redirected to the previous page. If we go to the main screen, you will see that we have the Splunk Stream application installed. Cool, we are ready to move on. What we are going to do now is to set up the independent stream forwarder. We will come back to the Splunk Enterprise side later on, but first of all we are going to install the Ubuntu box where we install the forwarder, the independent stream forwarder. So, and as I said before, we are going to download a Ubuntu Server. We are going to install a Ubuntu Server virtual machine rather than downloading the fresh ISO image to start the installation from scratch, which is going to take us a while. What I decided to do was to use some pre-built or pre-configured virtual machines, and so this is done by some guys called, or a group called OS Boxes. So actually you look for it, OS Boxes, in the internet. So you will see that these guys are providing virtual machines for VirtualBox and VMware of the different Linux distributions. Okay, so when it comes to Ubuntu, you have one specific, or you have different virtual machines for the different versions. In my case, I decided to go with Ubuntu Server 16.04, and this is the URL, so you don't need to search for it, so you can reuse this command line. And in order to download this big file, I'm going to use Axel, and this is because when you try to download this directly using the web browser, because that process is a single thread process and it looks like the bandwidth is limited for every single connection, it will take many different hours. So with Axels you can run a multi-thread download, you can start a multi-thread download process, and that's going to speed things up. So if you copy this link, so let's go to a different screen, and you paste it in here, what it's going to do is to start 5 threads, and it will download this file much quicker. So actually it will take some minutes, probably 3 minutes. This is increasing as the different threads start downloading things. You see 1.5, probably 2 megs. If not, the downloading rate is gonna be like 500 kilobytes or something like that, so which is much slower. Sorry. Okay, so while this is working, at the end of the process we will have this file. We will use 7-zip to unzip the file, because this is the format these guys, the OS Boxes guys, have used to compress the file. We will uncompress it, and what we are going to have is a VDI file, which is the virtual disk. And what we have to do is to create the virtual machine specifications, and then we have to attach the virtual disk to the virtual machine. So you go to this guide in here. So let me close this link. If you go to the guide, you have the process you have to follow in order to attach the virtual disk we are downloading from OS Boxes to the virtual machine that you are creating. Okay, so you can go over the guide and you will see that the process is very straightforward. So in my case, I'm going to create a two virtual CPUs virtual machine with 1 GB RAM. So this is going to be enough for the scenario I'm going to build, but it could be insufficient or it couldn't be enough for a production scenario. Okay, so don't take this as a reference for a production scenario, because it is not. This is just a test. And then we need to do the network setup for this virtual machine. So it's gonna be NAT, network address translation, and so that means the virtual machine is not going to be reachable from the outside world, and we need to do port redirection, port forwarding. The only 3 ports we need to redirect to the virtual machines are these 3: the 9985 UDP port for the NetFlow traffic coming in from the generator. Then I want to access the virtual machine through SSH, which is going to be handier than accessing it through the console itself. And finally the 8889, which is the independent stream forwarder web user interface, and this is going to tell us or this is going to give us information about if the NetFlow traffic is going out to the Splunk Enterprise instance. Cool. So once we have the virtual machine up and running, we should have a screen like this. So let me see if the downloading process is done. There you go. So finally it was super fast. Okay, so let me double check. This is the command we have to use. Control-C, Control-V, and this will start the process, the extraction process, and this is the virtual disk image. So while this is uncompressing, I'm going to start VirtualBox. And I'm going to create a new machine. So I'm going to call it independent stream forwarder machine, and this is going to be a Linux virtual machine and Ubuntu 64-bit. 1 megabyte is gonna be okay. We are not going to create, we are going to use an existing virtual hard disk. We're clicking here and we are going to add it, and this is it. We click open, we choose it, and we create the virtual machine. And then here we are going to set up the virtual machine. So when it comes to system, as I said before, I want to have a couple of CPUs. And when it comes to network, it's gonna be NAT, and then we need to do the port forwarding thing, and this is going to be UDP 9985 in the host IP, that means my laptop, and this is gonna be 9985 guest IP, which is the virtual machine. Whoops, not the IP but the port. Yeah, that's important. Okay, so the next one is gonna be the TCP 2222. The laptop is gonna be 22 in the virtual machine, and finally 8889 in the laptop is gonna be 8889 in the virtual machine. Okay, this is all done. We have the virtual machine properly created, the VDI was extracted, so it's time to start it up. Okay, Ubuntu is there, so it recognized So let's minimize this then. Let's remove this. Let's go to this one. Yeah. That's gonna be it. Much better now. Okay, so we are here. We have our virtual machine where we are going to install the Splunk in the independent stream forwarder. Then once we have everything up and running, we are able to access, and here we have the credentials. So there is a user, OS boxes, and osboxes.org is the password, and the same password is the root password. Okay, one more time. Over here we hit enter, osboxes, osboxes.org. And here I am. Cool. So everything is working as expected, and you will see there are some challenges that we are going to face in here, and one of those challenges is the network setup. So right now you try to ping the internet, you will see that there is no connectivity. That's expected, and for some reason the network card is disabled. So you click this link, you have the commands that I'm going to use in order to enable the network card, bring it up and get an IP address, dynamic IP address with the DHCP client. So these three commands are the commands that I have in here. Okay, so you cannot copy and paste them because basically it's something you cannot do in the console. So that's the reason, because I will set up an SSH connection just to make everything faster by copying and pasting things. But in this case we cannot make it. So the first thing we are going to do is identify which is the network device. In this case, as you can see, is EMP0S17. Probably is the same in yours the next time you are executing this exercise. But anyway, no, in this case it's different, S3, you see. Okay, so good to do it. And once you have it, you need to bring it up and then to set the IP address up by using the DH client application, and we have to do everything as root. Cool. So sudo su minus osboxes.org. Now if config enp0s3 app and dh client emp0s3 minus v, minus v. Okay, and now we have an IP address. You can see we got the 10.0.2.15 IP address, and this the 10.0.2.2 is the default route, and so it represents the IP address of the laptop from the virtual machine perspective. So there are many virtual network adapters created when you install VirtualBox and when you install Docker, and so those virtual adapters have their own IP address, and the IP address is what you are going to use to access the laptop itself. So in this case, this 10.0.2.2, actually if I type this or only route, so you will see that the default gateway is going to be 10.0.2.2, and so when we want the virtual machine access the Splunk Enterprise instance, we have to use that IP address. Cool. Let's go back to the article. The next thing we are going to do is to install the SSH server and to enable it. And again, this is something that we have in here, and it is a matter of following these steps. Okay, and so we need to be root in order to install packages, and it's going to be as easy as running this command. And actually we can get rid of this part and get rid of this part. Okay, we are here, apt get install open ssh / server, that's the server. Okay, let's update. First of all, probably the internal database is not properly updated. Open ssh, that's server. Okay, should be the same. Let me see if there is any typo. Yeah. Okay, so finally we got it. The next thing we are going to do is to check that it's enabled, and if not, we will enable it. Very quickly, service sshd status. Okay, it's up and running, so that means from now on I can access the virtual machine by using SSH, and I can leave this out. Okay, so let me see. I'm going to access the virtual machine by SSH in this window over here. So remember, we mapped the 2222 port in the laptop to 22 port in the virtual machine. So that's gonna be the way we can access the virtual machine, accessing ourselves in the port 2222 TCP port, by the way. Okay, as I did this before, so there are some conflicts. So let's remove this. Let's give it another try. osboxes.org. There we go. Okay, so from now on, everything that we have to do in the virtual machine is going to be through this terminal. In here, we can close this. It's all done. Let's move on. So the next thing in the virtual machine, so we have the virtual machine up and running. The network is working. We have the SSH server, and the next thing we are going to do is to install the independent stream forwarder. And so if you go to the documentation, so this is the documentation to deploy the independent stream forwarder, and this is actually what we are doing, and replacing the host name by the Splunk Enterprise IP address. So remember that the Splunk Enterprise IP address is going to be the default route for the virtual machine, which is 10.0.2.2. So if I copy this and I go back to the terminal, this is going to retrieve the installer from the Splunk Enterprise instance, and it will execute the installer by using sudo. That means it's going to install it as an administrator user, as the root user. And we type the password one more time, and this is downloading and installing the independent stream forwarder. So this will take a while. And so finally, the next challenge we are going to face is, by default, the independent stream forwarder is shipped with a System 5 init script, and Ubuntu 16 is using systemd for services initialization and services management. So that means there's a conflict, even though there is an integration, or there is a kind of bridge where systemd is able to execute System 5 init scripts. In our case, it's not working, so we get an issue, we get an error. Fortunately, there is someone who already had the problem, reported it in Splunk Answer, which is the Splunk community. And here you have the steps that you have to take in order to fix it. Basically, you need to kill the daemon, because even though you are getting an error when you are trying to start it up, the daemon is up and running. So first thing you have to do is to kill it, to remove it, then remove the init script just to prevent this happening one more time, and finally create the equivalent systemd script. And from this point on, you can use systemd natively, or you can start a stream forwarder, the independent stream forwarder, natively by using systemd. Everything is in here, and this is what we are going to copy and paste. So let's start by killing the daemon if it's up and running, and we need to root, so sudo minus, there we go. Okay, so in this case, because we didn't try to start it up, it is not there. What we can do is to remove script, there we go, and remove physically the file with the script. Now it's gone. Next thing is to create this new file, which is the systemd service. I'm going to use bi, and I'm going to copy and paste the service definition or service description. And so it looks like it's not properly copied. Okay, no problem. So description after service time exec start. There we go. The service is there. Now we need to enable the service, and this is the command to enable it. There we go. Now we have the systemd script, and we can start using service. As you can see in here, the service command is going to help us to handle the systemd service. Service, the name of the service is stream for fwd. Current status is dead, so that means it's stopped. So the next thing we are going to do is to start it. If we double check the status, there we go. Right now it's running, and this is part of the log file. Cool. This is good news. There we go. So the next thing we are going to do is to start setting up the setting up everything just to allow the NetFlow traffic ingestion. So we will configure things in the Splunk Enterprise side and also in the independent stream forwarder side. So let's start from the Splunk Enterprise side. So we need to go to the Splunk Stream app, and we will start the wizard. So actually it's super easy to configure everything, as we will see many different wizards helping us in the process. By the way, I can remove this. I will not use it anymore. So now we need to go to the Splunk Enterprise. We will see the wizard because it is the first time we are accessing the app. Skip the tour, and here we have two ways of collecting wired data. We can use the technical add-on, which is installed once you install the Splunk stream application. It's installed in the technical add-on as well in the same machine. There are many other ways of installing the technical add-on. In our case, we are going to use the independent stream forwarder, so that means we are going to choose the collect data from other machines. So we click here, we will remove this, and so you will see that the HTTP event collector head is already configured, and there is a token for Splunk stream. And this is the command that we used before, but so we didn't use Splunk So here is using the host name, we use the IP address, and we have an annoying message in here. This is a warning, and probably you might think this is going to work out, even though we have a warning message, but the reality is this warning message matters. And if you don't get rid of this message, you will not make it work. And this is what took me a lot of time to make this work. So keep an eye on this. We will come back to this later. Okay, this is done. Let's get started. This is the main screen, Splunk Stream main screen. And once we are here, what we are going to do is to configure Splunk Stream to handle NetFlow traffic. So by default it's disabled, and we need to explicitly specify that Splunk Stream has to ingest NetFlow traffic, and this new setup is going to be picked up by the independent stream forwarder once it's started. And actually, as right now is running in the background, it's going to take this configuration on the fly. These are the screens we are going to see in a moment, and we need to double check that everything is properly configured. Configuration, configure streams. As you can see, most of the protocols are enabled with the estimate option. And so here NetFlow is disabled, edit, enabled, and save. Done. If we go back to the configure streams and we filter out by NetFlow, you will see that is already enabled. This is good. So the next thing we are going to do is to get rid of this message. Okay, it is an annoying message and it impacts on the whole deployment. So if you don't get rid of it, it will not work. So in order to be sure that this is gone, we are going to see where we can double check that this is out once we take the action. So we go to configuration, distributed forwarder management, and then we click the install stream forwarders, we will get to this screen showing the annoying message. There we go. So here it is. Cool. So we need to come back to this screen once we take the actions in order to know that this is gone. So the configuration has to happen inside the Docker container. So we need to use this command in order to access the Docker container. Let's copy it. Let's go to the screen number 1, paste it. Now I'm inside. I'm inside as the Ansible user, but I'm in the Splunk home directory. So the next thing we have to do is to check the contents in this file, and here is where we have this set up. So this means when Splunk is starting up, the host property is going to be configured dynamically by checking the output of the hostname command. For some reason it's not working, and I'm not going to spend very much time because this is just a test. What I'm going to do is to override this default behavior. So in order to modify the default behavior, you can go to the inputs.conf and you modify, or you add actually a new entry for default, and you specify a static value, which is gonna be Splunk, which is the result of the hostname. Okay, so sudo vi and we add default, and host is gonna be Splunk. And there we go. That's pretty much it. The next thing we have to do is to restart the instance, and we are going to use the web user interface to do so. So we leave this, we go to settings, server controls, restart Splunk. Okay, and it will take some seconds, and I'm going to be redirected to the same page. Okay, all restarted. Back to the login screen. Once we log in, we are inside Splunk Enterprise, and let's double check that everything is okay and we got rid of that annoying message. Here we go. So no more warnings and we are good to go. Okay, so once the only thing we need to get from the Splunk Enterprise side is the token, the HEC token, which is in here, and I will come back to this later, because we need to set this up in the virtual machine. So this is step number 4. We go to the independent stream forwarder, and so what we have to do is to be sure that naming resolution is properly set up. We cannot work with the IP address any longer, and in order to have a proper naming resolution, what I'm going to do is to add this entry in the etc host file. I will double check that everything is working properly. So with the ping command I can see that I get the echo messages back. And finally we are going to do something similar to what we did before with the host property in the inputs.conf in the stream forwarder folder. Last but not least, we need to set up the stream forwarder by telling the forwarder what the HEC token is. Here we have, and then set up the NetFlow collector, which are these 3 lines in here. So everything is properly documented in this link. So you scroll down, you will see that this is something you need to set up. So here you need to replace this end by the indexer that you are accessing to. You could have many different indexers, and you are going to refer to the different indexers by a number. And the flow collector configuration is defined in here. So you can choose the different versions of NetFlow that you're going to use, if it is Cisco, if it is Juniper, and this is associated to the indexer you are working with. No, actually it's the different receivers. Sorry, so you can have multiple different receivers, and every receiver is gonna be configured in a different way. You could have many different interfaces. You have a machine with different network interfaces, and you could provide different IP addresses. In our case, it's gonna be very easy. We are going to use only one receiver, and this is going to be Cisco, NetFlow, and one single IP. Anyway, everything is in here. It's just a matter of copy and paste. We restart, and so hopefully everything is working properly. So let's go step by step. First of all, let's add this line to the etc, and this is not it. Now we need to go to the virtual machine, which is up here, hosts. Let's add this. There we go. And if I ping Splunk, I get a response back. Okay, that's good. Then we are going to go to this file in here, and I'm going to add this default stanza. There we go. And finally, we are going to edit this file. Oops. Nothing here. So in this case, we copy and paste everything. So if it happened before, we need to do this manually. namespaces. That's irrelevant, but it helps to debug things when you're having issues. So this is the IP. Okay, should be like this, perfect. And the only thing we have to change is the heck token, which definitely is gonna be different to the one I have in the article, because it was a different exercise, a different instance. So if we go to the HTTP event collector, we have the stream forwarder token, which is this one. We click, we copy, and finally we can paste in here. Okay, this is it. We are going to restart the service, and actually I'm going to stop it first of all. Stop. I'm going to remove the log files just to have a clear. Let's see where I am. Okay. Let's remove it. Let's start. And so if everything goes okay, we should have these lines in here. So found the data directory, hola, NetFlow receiver configuration defined, listening to this TCP port. So this should be what we have to see in here. So let's do so. Let's make it bigger, and there we go. So this is good news. Everything is info. We don't have any warning. We don't have any error, any fatal, and everything seems to be okay. In order to check that is actually okay, we can also access to the Splunk independent stream forwarder web UI, and this is what we are going to see increasing once we are capturing NetFlow traffic, which is going to be the next step. So we are going to use the NetFlow traffic generator, but we are going to use the dockerized version. The only thing we have to do is to provide the IP address of the NetFlow traffic sniffer, let's say, or collector, whatever you want to call it, which is going to be the independent stream forwarder, and the port where the independent stream forwarder is bound to, which is 99.95 UDP. Okay, and the IP address is gonna be again the laptop. Remember, the laptop has many different IP addresses, virtual IP addresses for the different virtual stuff, Docker and VirtualBox. In our case, the main IP address, which is the one bound to the Wi-Fi network card, is redirected, or traffic to the different ports defined on top of this IP address are redirected to the Docker container on the virtual machine. So in order to know which IP address I have configured for the Wi-Fi network card, I can use the IP address command, and we're going to do this in window number 2. Let me make this bigger. IP address, and this is my Wi-Fi net. No, not really. Let's see where it is. Okay, yeah, this is it. Yeah, so this is my network card. It's 172.20.10.11, and this is the one, the IP address I'm going to use is the different one, a different one, to the one I have here in this screen, because I'm using a different network. So what I have to do is to use this command line in here. The IP address is going to be this one, and TCP port is going to be 99.95, and it will show a message saying that it's doing stuff. There you go, sending NetFlow data to a collector IP. That means there is something bound to this IP and TCP port, because otherwise you get an error. Okay, so we have Splunk Enterprise, we have the VM, and we have the NetFlow generator, NetFlow traffic generator. How do we check that everything is up and running? So let's see what we get in the independent stream forwarder web page, web interface. You see there is traffic going out, and this traffic is going to actually the Splunk Enterprise instance, and we are going to check that this is it by accessing the search and reporting app and searching stuff inside the main index. Skip it. You see there is stuff going on. If we go to data summary, you will see that there is data coming from the OS boxes virtual machine, which is the virtual machine we spun up before. There are many different sources in here. Okay, and finally we have many different source types, and being one of them NetFlow. So actually if we type index main, we have it in here, and we search for the last 15 minutes, you will see that there we go. Here we have NetFlow stuff. And so here we go. Let me go back to the Splunk Stream application just to see if there is something else in here. Okay, nothing in here because we are not analyzing any traffic. Oh wait, yeah, actually the generator is sending some traffic by application, so I can see many different stuff and analysis. Okay, this is it. Actually, the most difficult thing is just to set up everything properly, and so this has been demonstrated, and hopefully the next time I have to use this, I can do it very quickly and I don't spend very much time on it. Okay, bye bye. Enjoy the video.